By now, we have talked quite a bit about limits, so I think that it is time to get a little bit pickier and start classifying different types of limits. For example, double-sided limits versus one-sided limits. In all of the examples that we have discussed so far, they have all been examples of two-sided limits, but I'm going to go over that carefully and I will tell you exactly what the difference is all about. Let's consider the following function. And we have been studying this function quite a bit. In fact, we started this video with this function. We said a while ago that the limit as x approaches 0, the limit as x approaches 0 of f of x, this limit over here is equal to 1. And the idea was the following. We examined what happens to the y values as x approaches 0 from the left. We said that as x approaches 0 from the left, the y values are moving towards 1. As x gets really, really close to 0, the y values are climbing all the way towards 1. Similarly, in the other direction, we're now moving towards 0 from the right. As we move towards 0 from the right, the y values are also getting closer and closer to 1. So this is why we made this conclusion right here. So now let's work through terminology. It takes some effort to write this phrase every time that we have to do so. As x approaches 0 from the right, the way that we're going to write this symbolically from now on is like this. X, arrow, meaning approaches, 0. And to denote from the right, you're going to put a tiny little plus above in the place of an exponent. Similarly, as x approaches 0 from the left, you're going to go x, arrow, meaning approaches, 0, and a tiny little exponent on top. So what is really happening is the following. If we look at the very first expression, imagine that you have your function right here, and this is what you have. You are approaching 0, but you are approaching 0 from the right. So then you know that the way that you're going to denote that is by saying x, arrow, 0 with a tiny little plus on the right. And then for the left direction, same idea. Imagine now that you have this piece of the graph right here. You are now approaching 0. So here is 0. You are approaching it from the left. So symbolically, you're going to go x, arrow, 0, and a tiny little negative right above 0. So this is now saying as x approaches 0 from the right, as x approaching 0 from the left. I should better mention here that sometimes there are some textbooks that instead of saying from the right, they say from above. Saying above and saying right is the same thing. And instead of saying left, some textbooks will say below. As x approaches 0 from below. From below means from the left. As x approaches 0 from above. From above means from the right. So now that I have a way to talk about approaching 0 from the right and approaching 0 from the left, I can talk about the limit as x approaches 0 from the right. For example, imagine that I write the following expression. The limit as x approaches 0 from the right of my function f of x. Let's go back to this function. This is our f of x. We are approaching now 0 from the right. We said that the y values are climbing and climbing towards 1. So then I can write here that this is going to be equal to 1. Similarly, I can write the limit as x approaches 0 from the left of f of x equals, let's go back to the function here. Now we are approaching 0 from the left. Look at the y values, they're going up to 1. So then we write that this is equal to 1. And what is really nice about these limits is that now we are specifically talking about what the function is approaching on one side of 0 and what the function is approaching on the other side of 0. So each side at a time. These limits have a special name. They are called one-sided limits. Okay. In particular, this is called over here, so this limit right here is the right hand limit, because it is talking about the limit of the function on the right side of 0. And this one right here is talking about the left hand limit. Again, because it is talking about the limit of the function on the left of 0. Now, in the case of this function right here, it happens that the limit as x approaches 0 from the right of f of x, the right-hand limit, is equal to the limit as x approaches 0 from the left. So the right-hand limit is equal to the left-hand limit. And whenever that happens, whenever the one-sided limits are identical, then we say that the double-sided limit exists. The limit as x approaches 0 of f of x is also equal to 1. And this limit right here, notice how there is no plus or minus, because now this is telling us that the right-handed limit is equal to the left-handed limit. So this limit right here that I circled in green, that limit is called the double-sided limit. So this is called the double-sided limit. A double-sided limit says that the one-sided limits are identical. It says exactly what we have here, that the limit from the left is identical to the limit from the right. What I want to do here now is to make this argument of one-sided limits and double-sided limits more general. If you notice, I am now working with any x value, such as a. A is a variable. In the previous, with the previous function, x was 0. We were approaching 0 from the left and from the right. Now we're going to be talking about approaching a from the left, approaching a from the right, and then we're going to be talking about or referring to the limit as being L, not just being 1. So we want to generalize our previous discussion. So working through that, now with variables, the idea is the same as before. If I want to talk about the one-sided limits, let's do the left-hand side limit first. We're going to have the limit as x approaches a from the left of the function f of x. When I look at that limit right here, as x is getting closer and closer to a from the left, the y values are getting closer and closer to L. So therefore, the limit appears to be L. Now the limit from the right or from above. The limit as x approaches a from the right, so a tiny little plus above, of f of x is equal to, again, x is approaching a from the right. If you look at the y values, they are approaching L. We're going to say is equal to L. And because both of these limits are equal, then we know for sure that the limit as x approaches a of f of x is going to be equal to L as well. I want to elaborate on this. Suppose that we know that the limit as x approaches a of f of x equals to L. Then what you know immediately is the following. What you know is that the limit as x approaches a from the left of f of x is going to be equal to the limit as x approaches a from the right of f of x. In both of those limits, that's going to be L and that's going to be equal to L. So saying that the limit as x approaches a of f of x is equal to L, this is equivalent to saying that the one-sided limits are identical as well. They have the same value for the limit. Everything is equal to L. In rehearsing terminology, this is called a double-sided limit. And double-sided because the limit from the left of A is equal to the limit from the right of A. And these ones over here are one-sided limits. One limit is only talking about what happens to f of x as x approaches a from the left, this one right here, and the other sided limit is talking about the limit of the function as x approaches a from the right. And whenever we don't put the plus or minus on top, we're talking about the double-sided limit. And if the double-sided limit is equal to L, we are saying that the left-hand limit is equal to the right-hand limit. So just one major understanding here, or let's say agreement, is that if it happens that the limit as x approaches a from the left of f of x is not equal to the limit as x approaches a from the right of f of x. Sometimes that happens. I can draw a quick picture right away. Imagine that we have a right here, and we have a function such that on the left of a, the function approaches this number, let's call it L, and let's say that on the right of a, the function approaches another value. Let's call this open circle M. So we have M for the open circle, and we have L for the dot. So look at this function. This function right here is showing that the limit, the left-handed limit, the limit as x approaches a from the left of f of x is equal to L. And it is also showing that the limit as x approaches a from the right of f of x is equal to M. And clearly, L does not equal to M. So what do we conclude? Therefore, the double-sided limit does not exist. The limit as x approaches a of f of x is undefined or does not exist. My shortcut for writing does not exist will be D and E. Whenever you see that I write D and E, that really means does not exist. So for the double limit to exist, the one-sided limits have to exist, but they have to be equal to each other. Here, the left-hand limit exists, is equal to L. The right-hand limit exists and is equal to M, but they are not equal to each other. They are unequal. So because the one-sided limits are unequal, then the double-sided limit does not exist. Let's look at this example right here. Consider the function h of t. H of t is equal to 0 when t is less than 0. So you can see that right here. And then if t is greater than 0, then h of t is going to be 1. Constant on the left of 0 and constant on the right of 0. But on the right, the y values are equal to 1, and on the left, the y values are equal to 0. So what immediately we can talk about the one-sided limits and the double-sided limit. So imagine that what we want to investigate is what is the limit as t approaches 0 of our function h of t. What is that limit equal to? And this is the double-sided limit. So to talk about a double-sided limit, then that means that I have to consider two cases. I have to analyze the limit as t approaches 0 from the left of h of t, and I also have to analyze the limit as t approaches 0 from the right of h of t. So let's do the left side, the left-hand limit. This limit right here, let's see, as t is approaching 0 from the left, the y values are consistently equal to 0. So I am going to say that this limit is equal to 0. Let's look at the right-sided limit. As t approaches 0 from the right, so right here, t is getting closer and closer to 0 from the right, look at the y values. They are at a height of 1 consistently. So then this limit over here is equal to 1. Well then, what does that mean? That means that the limit as t approaches 0 of h of t, the double-sided limit, does not exist. Why? Well, because the limit as t approaches 0 from the left of h of t doesn't equal to the limit as t approaches 0 from the right of h of t, right? 0 doesn't equal to 1. So the one-sided limits, they beautifully exist, but the double-sided limit doesn't exist because the one-sided limits are unequal. That's all that it means. Let's look at another example, example number 2. So this example is saying that the graph of a function g is shown below. We can see it right here. Use it to state the values, if they exist, of the following. So here is A. We have to try to find the limit as x approaches 2 from the left. So this is a one-sided limit. So let's start here. A. What is the limit as x approaches 2 from the left of g of x? Let's go to the graph. Notice how here is 2, right here. We are approaching 2 from the left. As we do that, as I am approaching 2 from the left, I'm going to do that in yellow. Look at the y values. They are on this part of the graph, right here, right here, right here. So then we notice that the limit is equal to 3 because we are approaching exactly this value right here, which is equal to 3. So then I am going to claim that this limit is equal to 3. Now let's do part B. Part B is asking for the right-hand limit, the limit as x approaches 2 from the right of g of x. So again, I am approaching 2 from the right. I'm going to do that in green right here. Now look at the y values. For an x value on the right of 2, I am now on this other piece of the graph. It seems as if we are approaching 1, not 3. So then I'm going to say 1. So what is that telling me about C? C is now asking me a question about the double-sided limit at x equals 2. What is the limit as x approaches 2 of g of x? And because the one-sided limits at 2 are different, then the double-sided limit does not exist. So I'm going to say D and E doesn't exist. All right, beautiful. Now let's go to D, right here. They're asking for the limit as x approaches 5 from the left of g of x. So this is the left-sided limit at 5. So using the graph, I am now approaching 5 from the right. So if I start going up to my graph, the y values are approaching 2. So then I'm going to say over here 2. And then I'm going to go to E. E is asking for the right-hand limit, the limit as x approaches 5 from the right of g of x. So when I do that, I am going to go up to my graph, and I am approaching 2 as well. So I am going to say 2. Now, part F of the question is asking what is the double-sided limit at 5? Does it exist in this case? And in this case, I'm going to have to say yes, it exists. And it's going to be equal to 2. And I know that because the one-sided limits, the limit on the left of 5 and the limit on the right of 5 exist, and they are identical. This is a great example, though. Let me erase these marks right here for now. This is a great example to show that in this case, the value of the limit doesn't equal to the value of the function. So just another reminder that the value of the limit doesn't have to equal to the value of the function at 5. What is important is what happens as we approach 5 from the left and from the right. And as we approach 5 from the left, the y values are on the actual curve above, right here. Those y values are approaching 2. They're not approaching 1. This is 1 right there below. So 1 is right here. That's the value of the function. But this is now the limit. The limit is 2, not 1. Let's finally look at one more example. Example 3. Let us analyze the function f of x, which is equal to the absolute value of x over x around x equals 0. And when we talk about analyzing, we want to find out what is the limit of the function at 0. So in other words, will this function have a limit? In other words, the limit as x approaches 0 of f of x. Does that exist? Remember, to be able to to be able to determine whether the limit of a function exists at 0, I'm going to have to investigate what happens to the one-sided limits. What is the limit as x approaches 0 from the right of f of x? And also, what is the limit as x approaches 0 from the left of f of x? I'm going to have to figure that out. And what I want to find out is that they're equal to each other. In other words, I want the two limits to be identical. If the two limits are identical, then the limit at 0 exists. The double-sided limit exists. All right, in order to do that, why don't we start with the graph? We're going to have over here, let's draw the x-axis. Let's draw the y-axis right here. And let's look at the function f of x. I don't want to use a table of values. I want to do this in a more mature manner. So I am going to go ahead and revisit my definition of absolute values. Long time ago, I'm going to do that in green here on the top corner. By definition, the absolute value of A is equal to A if A is greater or equal than 0. So if A is positive or equal to 0, the absolute value of A is A. No absolute values is necessary. And if A is less than 0, the absolute value of A is negative A. And that makes sense. If A is negative, let's say negative 2, then the opposite of negative 2, in other words, negative 2, is positive. So utilizing this definition allows me to rewrite this function as x over x, which is equal to 1. And that happens if x is greater than 0. And we are going to say negative x over x, which is equal to negative 1, if x is less than 0. I will not include 0, because if x is equal to 0, then the function is undefined. So then that means that in this case, right here, the only two cases that I consider are x's that are bigger than 0 and x's that are less than 0. I am not going to be able to include 0. 0 is not in the domain of the function. So then, when we do that, the entire function seems more manageable. Here we have 1, let's say, and somewhere here we have negative 1. And what we really have, I'm going to put an open circle at 0 because the function is undefined at 0. When x is positive, the function goes to the right like this. When x is negative, it goes to the left. And in both cases, the function is constant, so horizontal. So just like this. Let me label the axis. This is the y-axis and this is the x-axis. And again, the open circles here are showing that 0 is not in the domain of the function. So now we're going to talk about the one-sided limits. So you're going to notice that the limit as x approaches 0 from the left of f of x is equal to negative 1. And the limit as x approaches 0 from the right of f of x is equal to 1. But negative 1 does not equal to positive 1. So therefore, the limit at 0 of f of x cannot possibly exist, does not exist. So even though the one-sided limits exist by themselves, they exist because they are not equal to each other. The double-sided limit, in other words, the limit at 0, cannot possibly exist.